welcome to another video lesson. So last time you have learned about arithmetic sequence. Arithmetic sequence is a sequence formed by adding the same number over and over again in every term each time. Say we have 5, 10, 15, 20, 25. It's an example of an arithmetic sequence because we are adding a constant 5 in every term each time. Also, you have learned about finding the nth term of an arithmetic sequence by using the formula a sub n is equal to a sub 1 plus the quantity n minus 1 times d, right? Now, in this lesson, you are going to learn about another type of sequence, and that is geometric sequence. Now, here are our objectives for this lesson. At the end of this lesson, you would be able to recognize sequences that are not geometric, apply your knowledge of geometric sequence to everyday life, apply the relevant formula in both theoretical and relevant applications, and calculate the value of the first term, the common ratio, and the general term of a geometric sequence. Alright, now let us start the lesson with analyzing this problem. A ping pong ball is dropped from a height of 16 feet and always rebounds 1/2 of the distance fallen. How high does it rebound the 5th time? Did you understand the problem? Now let's put it this way. I have here a ping pong ball and I'm gonna drop this from a height of 16 feet. Now the problem says that the rebound height is always 1/2 the drop height. And we are asked to look for the 5th rebound height. Okay? Alright, now let's try dropping this ball from a height of 16 feet. Okay. Alright, did you see that? Now let's take a look at the path taken by the ping pong ball. So here's the path taken by the ping pong ball. Okay. In this path, you will notice that the ping pong ball always rebounds 1/2 its distance fallen. Okay. Right. Our dropped height is at 16 feet. Okay. Now, based from the problem, our rebound height is always 1/2 its drop height. Now, our first rebound height will be at this point. Okay? That will be 16 times 1/2 is 8. Second rebound height is at this point. That will be 8 times 1/2 is 4. Third rebound height will be at this point. That is 4 times 1/2. That's 2 feet. Next rebound height will be at this point. That will be 2 times 1/2. That's 1 foot. Okay? Now this is our first rebound height. It's 8 feet. Second rebound height, 4 feet. Third rebound height, 2 feet. Fourth rebound height, 1 foot. Now what will be our 5th rebound height? You just have to multiply 1 foot and 1/2. So that's 1/2 or 0.5 feet. Again, our 5th rebound height is 0.5 feet. Okay? Now, as you will notice, every height after this dropped height was obtained by multiplying a fixed number 1/2, right? So from 16, multiply that to 1/2, that's 8. So 1/2 of 8, 4. 1/2 of 1/2 of 4, is 2. 1/2 of 2 is 1. 1/2 of 1 is 0.5. Now this process actually represents a sequence, and that is geometric sequence. Okay, geometric sequence or geometric progression, it is a sequence in which the next term is obtained by multiplying the preceding term by a common multiplier called common ratio. Okay, remember that arithmetic sequence is adding the same number over and over again in every term each time. Geometric sequence, on the other hand, is multiplying a constant number over and over again in every term each time. Okay? And that constant number being multiplied to every term is called common ratio. Okay, given a sequence, let's identify if it's a geometric sequence or not a geometric sequence. Example number 1, we have 3, 6, 12, 24, 48. Let's first consider the first term and then the second term. Now, how do we get 6 from 3? We multiply 3 and 2. So 3 times 2, we have 6. Let's see whether it's true with the second term and the third term. 6 times 2 is 12, and that's correct. Now 12 times 2 is 24, 24 times 2 is 48. Now we multiply a constant number 2, therefore this is an example of a geometric sequence with a common ratio 2. Okay? Now second example, -1, 4, -16, 64, and -256. This sequence is multiplying -4. -1 times -4 is +4. 4 times -4 is -16. -16 times -4 is +64. 64 times -4 is -256. Same with the first example, we multiply a constant number -4, so this is also a geometric sequence with a common ratio -4. Next example, 15, 30, 45, 60, 75, 90. If we are going to consider the first term and then the second term, we can say that we multiply 15 by 2 to get 30. Now, if we're going to multiply 30 by 2, the answer should be 60. It should not be 45. So, we cannot consider multiplying by 2 in this sequence. I guess this is adding 15. 15 plus 15 is 30. 30 plus 15 is 45. 45 plus 15 is 60. 60 plus 45 is 75. And 75 plus 15 is 90. So adding the same number, adding a constant number, this means it is an arithmetic sequence and it is not a geometric sequence. For our third example, 15, 30, 45, 60, 75, 90. Let's consider the first term and then the second term. If we're going to multiply 2 and 15, then we can get 30. And if you multiply 30 and 2, we will get 60. But our third term is 45. So we cannot consider multiplying by 2 in this sequence. Well, I guess the pattern for this sequence is just adding 15. 15 plus 15, we have 30. 30 plus 15, we have 45. 45 plus 15 is 60. 60 plus 15 is 75. 75 plus 15 is 90. So, this means that this is not a geometric sequence, but rather an arithmetic sequence. Now, let's proceed to common ratio. Common ratio is a constant multiplied to each number to find the next term in a geometric sequence. And we write common ratio as small letter r. We have the sequence 16, 8, 4, 2, 1. We are going to find the common ratio by dividing a term by its preceding term. So here, let's use 8. The preceding term of 8 is 16. So 8 over 16, simplifying that, is 1/2. Next, let's use 4. The preceding term of 4 is 8. So 4 over 8, that's also 1/2. Next, 2. The preceding term of 2 is 4. That's 2/4. And that's also 1/2. And lastly, we have 1. The preceding term is 2. That's also 1/2. So, our common ratio for the sequence 16, 8, 4, 2, 1 is 1/2. So, same with the arithmetic sequence, we also have a general term for a geometric sequence. our general term is a sub n is equal to a sub 1 times r raised to n minus 1. Our a sub n is the nth term, a sub 1, the first term, r, common ratio, n is our number of terms. You have to memorize this formula. Again, the general term of a geometric sequence is a sub n is equal to a sub 1 times r raised to n minus 1. Let's try answering some examples. Find the common ratio of the geometric sequence 6, 12, 24, 48. Okay, now what to find for this problem? We are asked to find the common ratio or R. Okay, now in finding the common ratio, again, we have to divide a term by its preceding term. So let's consider 12 divided by the preceding term, 6. 12 divided by 6 is 2. Next, let's use 24. 24 divided by its preceding term, 12, that's 2 also. Next, 48 divided by the preceding term, which is 24, that's 2 also. Therefore, our common ratio for the sequence 6, 12, 24, 48 is 2. Next, find the common ratio and the next two terms of the geometric sequence 243, 81, 27, 9, and so on. Now, we are asked to find the common ratio and the next two terms of the sequence 243, 81, 27, and 9. So let's put two blanks after 9. Okay, common ratio again, we divide a term by its preceding term. Let's consider 81 divided by 243, that's 1/3. Next, 27 divided by the preceding term, 81. Simplifying that, that's also 1/3. And we have 9 divided by the preceding term, 27. Simplifying, that's 1/3 also. Therefore, our common ratio for the sequence is 1/3. Since we already have the common ratio, we are now going to use that common ratio to find the next two terms of the sequence. We just have to multiply it with 9. So 9 times 1/3 is 3. 3 times 1/3 is 1. Therefore, the next two terms of the sequence are 3 and 1. Okay, now using the definition of geometric sequence, determine the next four terms given the first term as 5 and the common ratio is 4. Now for this problem, let us first identify the given. The given are the first term or a sub 1, it's 5, and then the common ratio is 4. Now we have this one, our first term again is 5. We are looking for a sub 2, a sub 3, a sub 4, a sub 5. Since we already have the common ratio, let's use that to find the next four terms. So 5 times 4 is 20, 20 times 4 is 80, 80 times 4 is 320, 320 times 4 is 1280. Now, these are now the next four terms of the sequence with a first term of 5 and a common ratio of 4. 20, 80, 320, and 1280. Let's have some examples on how to use the formula for finding the nth term of an arithmetic sequence. Remember the formula? We have a sub n is equal to a sub 1 times r raised to n minus 1. Okay? Now example number 1. Determine the 8th term of the geometric sequence with 9, 27, 81, 243, and so on. Again, let's start with the given. Our given are first term or a sub 1 is equal to 9, n is equal to 8 because we are looking for the 8th term. Our r, common ratio, let's use 27 and its preceding term is 9. So 27 divided by 9 is equal to 3, and then we are looking for the 8th term, so a sub 8. It's a sub 8. Again, our formula, a sub n is equal to a sub 1 times r raised to n minus 1. So we have to change n here into 8. Okay? So a sub 8 is equal to a sub 1, that's 9. Our common ratio is 3 and 8 minus 1. After substituting all the given, we evaluate. A sub 8 is equal to 9, copy 9, copy 3, then 8 minus 1 is 7. So, this will become 3 raised to 7. How are we going to evaluate 3 raised to 7? It's multiplying 3 7 times to itself. So, 3 times 3 times 3 times 3 times 3 times 3 times 3. That becomes 2,187. So a sub 8 now, 9 times 2,187 is 19,683. So that is now the answer. The 8th term of the geometric sequence 9, 27, 81, 243 is 19,683. Now it's your turn to answer. Determine the 10th term of the geometric sequence with a sub 1 is equal to negative 2 and r is equal to 4. Now you have to pause first the video and answer the problem. Once you're done answering, go back to this video to check your answer. Let's answer now. First is you have to identify the given. Now our given are, the first term is negative 2, n is 10, r is 4, and we are looking for the 10th term or a sub 10. Next is write the formula a sub n is equal to a sub 1 times r raised to n minus 1. Then we have to substitute all the given in the formula that we have. Change n to 10. Our a sub 1 is negative 2, r is 4, and is 10. Then evaluate this equation. Again, a sub 10 will now become negative 2, copy 4, 10 minus 1 is 9. And remember that 4 raised to 9 is 4 multiplied to itself 9 times. So that's 262,144. Now our a sub 10 will now become negative 2 times 262,144 is negative 524,288. So that will now be our answer. The 10th term of the geometric sequence with a sub 1 is equal to negative 2 and r is equal to 4 is negative 524,288. Right? Did you get the same answer? Alright. Example number 2. In the geometric sequence 4, 8, 16, 32, and so on, which term is 1024? Now in this problem, we are asked to find the term position of 1024. Okay, let's identify first all the given. A sub 1 is equal to 4. Our r is equal to 2. A sub n is equal to 1024. And we are looking for what is n. Our formula, a sub n is equal to a sub 1 times r raised to n minus 1. Let us substitute all the given to the formula. A sub n is equal to 1024. A sub 1 is equal to 4. R is equal to 2. Then copy n minus 1. Now following PEMDAS, we cannot multiply 4 and 2 here. What we have to do is to eliminate 4. So we need to multiply 1/4 on both sides. Okay, 1024 times 1/4 is 256. Then 4 times the quantity 2 raised to n minus 1 times 1/4 is 2 raised to n minus 1. Okay, now at this point, to solve for n, we have to write 256 into exponential form with the same base as 2 raised to n minus 1. Okay, now we can write 256 as 2 raised to 8. Then we have 2 raised to n minus 1. Since we already have the same bases, we can now work on the exponents based on logarithm rule. Now 8 is equal to n minus 1. To solve for n, we have 8 plus 1 is equal to n is equal to 9. Now, therefore, 1024 is the ninth term of the geometric sequence for 8, 16, 32, and so on. Okay? Right, now it's time for you to try finding n for a given geometric sequence. Okay? Now here's the geometric sequence. 3, 36, and so on. You have to find the term position of 5184. Now pause first the video. Once you're done answering, go back to this video to check your answer. Alright, now here's how we do it. First, of course, you have to identify all the given. We have a sub 1 as 3. Our r is 12. A sub n is equal to 5184, and we are looking for what is n. Our formula, a sub n is equal to a sub 1 times r raised to n minus 1. Substitute all the given. A sub n is equal to 5184. A sub 1 is equal to 3. R is equal to 12. Then copy n minus 1. Next to this will be, we have to multiply 1/3 to on both sides. So 1/3 times 5184 is 1728. Next, 3 times the quantity 12 raised to n minus 1 times 1/3 is now 12 raised to n minus 1. And then we can write 1728 to 12 raised to 3. Then 12 raised to n minus 1. Okay? Since we already have the same basis, we work on the exponents. So 3 is equal to n minus 1. We can write this one as 3 plus 1 is equal to n, so our n is equal to 4. Therefore, in the geometric sequence, 3, 36, 5184 is the fourth term. Did you get the same answer? Example number 3. Determine the first term of the geometric sequence whose fourth term is 108 and the seventh term is 2116. So here, we are going to solve for our first term and also our common ratio. Okay? Now the given are a sub 4, 108, a sub 7, 2916, and of course our n is 7. Okay, now we can write our sequence as this one. Now the only given are a sub 4 and a sub 7. Now take a look at our formula. Here in our formula, we cannot solve if there are two missing variables. Okay, what we need to do is to consider this part, 108 until 2916, for us to be able to solve for what is our common ratio. Alright? Now, let's change our 108 as our a sub 1 and then 2916 as a sub 4. And of course, our n for that will be 4. Using our formula, let's substitute all the given. Our a sub n is 2916, a sub 1 is 108, copy r, change n to 4, and then minus 1. Next, copy 2916, copy 108, then 4 minus 1 is 3. Now let's isolate r cube at the right side of the equation. So we can divide both sides by 108, or we can multiply both sides by the reciprocal of 108, which is 1 over 108. Okay, now let's multiply 2916 times 1 over 108, that's 27. Next, 108 r cube times 1 over 108 is r cube. Next to that, let's get the cube root of both sides. The cube root of 27 and the cube root of r cube. Now the cube root of 27 is 3, and then cube root of r cube is r. Now we already have our common ratio for this geometric sequence as 3. Okay, now let's go back to our problem. Since we already have the common ratio, then we could already solve for our a sub 1. Using our formula, we have a sub n as 2,916. Our a sub 1, copy a sub 1, our r is 3, and then n is 7 minus 1. Now 2,916, a sub 1, 7 minus 1 is 6. And let's evaluate. 2,916 is equal to a sub 1. 3 raised to 6 multiplying 3 to itself 6 times. That's 729. Then to solve for a sub 1, we can divide both sides by 729 or multiply both sides by the reciprocal of 729, which is 1 over 729. Okay? Now, 2,916 times 1 over 729 is 2,916 over 729. Then, copy a sub 1, 729 times 1 over 729 is 729 over 729. This one is 4. Then, 729 divided by 729 is 1. So, it's okay if we're not going to write 1 here anymore. So therefore, our a sub 1 for this sequence, for this geometric sequence is 4. Now I'm giving you the task to check whether our answer is correct. You write 4 as our a sub 1 and then you multiply each term, every term each time by 3 until you come up with 2,916 as our a sub 7. Answer again. The fifth term of a geometric progression or geometric sequence is 64 and the eighth term is 512. Find the common ratio in the first term. Now this is just the same with the previous example. I want you to pause first the video. Once you're done answering, you go back to this video to check your answer. Alright, now again, first is to identify all the given. Our a sub 5 is 64, a sub 8 is 512, our n is equal to 8. We are looking for our common ratio in the first term. Now we write our sequence as this one. Okay, our formula again, a sub n is equal to a sub 1 times r raised to n minus 1. Now here we have to consider the part of a sub 5 until a sub 8 to get our common ratio, right? Now, let's change 64 as our a sub 1 and 512 as our a sub 4. And of course, our n is equal to 4. Using our formula, substitute all the given. Our a sub 4 is 512, a sub 1 is equal to 64, r, copy r, change n to 4 minus 1. Next, 512 is equal to 64. 4 minus 1 is equal to 3. Now, let's divide both sides by 64 or we can have it multiplied by the reciprocal of 64, which is 1 over 64. 512 times 1 over 64 is 8. Then 64 r cubed times 1 over 64 is r cubed. Now, let's get the cube root of both sides. The cube root of 8 is equal to the cube root of r cubed. Now, the cube root of 8 is 2, and the cube root of r cubed is r. Now, in this sequence, our common ratio is... Now, let's go back to the problem. Since we already have our common ratio, and we have our a sub 5, a sub 8, we can now solve for our a sub 1, right? Now, let's use the formula again. Our a sub 1, our a sub n is 512, copy a sub 1, and then our r is 2, copy 8 minus 1, then 8 minus 1 is equal to 7. Now we have 2 raised to 7. 2 raised to 7 is 2 multiplied to itself 7 times, that's 128. Now we can divide both sides by 128 or multiply both sides by the reciprocal of 128, which is 1 over 128. Now 512 times 1 over 128 is 512 over 128. Copy a sub 1. 128 times 1 over 128 is 128 over 128. Now 512 divided by 128, that's 4. This 1 becomes 1, and then this is a sub 1. Okay? Now our a sub 1 is 4. Now I'll be giving again the task to check whether our answer is correct. You write 4 here, and then multiply every term each time by our common ratio 2 until you get to our a sub 8, which is 512. Alright? And now for our last example, this is a word problem. In an infected pig by African swine fever virus, the number of virus increases 5 times every hour. If the initial number of virus is 1000 at 1 p.m., what is the number of virus at 6 p.m.? Okay, now here are our given. Our a sub 1, or first term, will be 1000 because it's the initial number of virus at 1 p.m. Okay? Next will be our common ratio will be 5 because the number of virus increases 5 times every hour. And then we are looking for a sub 6 because the question here is what is the number of virus at 6 p.m. So our n will be 6. Alright? Now using our formula for geometric sequence, we have this one. Substitute our given. That will become a sub 6 is equal to a sub 1, 1000. R is 5, n is 6, minus 1. Then a sub 6 is equal to 1000. 6 minus 1 is 5. Then 5 raised to 5 is 3125. Now our a sub 6 will now become 1000 times 3125 is 3,125,000. Okay? Now at 6 p.m. the number of virus will now become 3,125,000. Now you try also solving this word problem on geometric sequence. Dr. Face Mask saved 100 pesos in January. Suppose he saved twice the amount he saved the previous month. How much money he must save in the month of December? Okay, now I want you to pause first the video. Once you're done answering this problem, you go back to this and check whether your answer is correct. Alright? Okay, now let's solve the problem. Here are our given. For our first term, that will be 100 because it's the amount saved by Dr. Face Mask in the month of January. Now, our common ratio is 2 because Dr. Face Mask saved twice the amount has saved the previous month. Okay? Then, we are looking for our a sub 12 because remember that in a year, December is our 12th month. Okay? Now let's use our formula. Substitute our given. That will become a sub 12 is equal to a sub 1, 100. Common ratio is 2. Then n is 12 minus 1. Now a sub 12 is equal to 100. 12 minus 1 is 11. Now 2 raised to 11 is 2048. Our a sub 12 now is 100 times 2048 is 204,800. So therefore, in the month of December, Dr. Face Mask must save 204,800 pesos. Okay? Now, I hope you got also the same answer. For STE students, please do answer this enrichment activity. How many terms are in the geometric sequence? 6, 3, and so on until 3 over 64. How much would you have to save on the 11th day if you had set aside 50 pesos on the first day, 100 pesos on the second day, 200 pesos on the third day, and so on through the period? And lastly, find x if the sequence 3x, 4x over 3 is A, an arithmetic sequence, B, a geometric sequence. Okay, thank you so much, and I hope you already mastered geometric sequence, and please do subscribe to this channel, Math Tindi, for more video lessons. Again, thank you so much, and God bless us all.